Hey guys, welcome to Mestris. Today we will be discussing a question on fluid pressure and measurements, which was asked in GATE 2003. So let's read the question first. Two pipelines, one carrying oil with mass density 900 kg per meter cube and other water, are connected to a manometer as shown in figure. By what amount the pressure in the water pipe should be increased so that the mercury level in both the limbs, the manometer, becomes equal. The mass density of mercury is 13,550 kilogram per meter cube and acceleration due to gravity is given as 9.81 meter per second square. So here we have two pipes, one containing oil and other containing water. So this is going into the plane. These both pipes are going into the plane. So these two pipes are connected using a manometer, a mercury manometer. So this is mercury and the initial levels are given. So initially the oil will have a pressure, let's say P0, and water also will have a pressure PW. That we can understand because there is a level difference and in the manometer. So these pressures can be different. So oil have a pressure at this point and water have a pressure PW at this point. So the question is how much extra pressure that let us call this as delta P. How much delta P should be increased in the water so that the manometer have exactly the same level in both the limbs, in the right limb and the left limb. The level of mercury will be same. So first, we will try to find how much this distance will be. So if this is the final equal levels in both the limbs, the amount of mercury that is decreased here will be the same as the amount of water that is increased here. So this should be essentially half of 20. That is, this will be 10. This will be 10 centimeters. Okay. So let us try to draw the desired final figure. So what we actually want this system to be. So this will be the final state of the system that we want. So first we want to find these heights. So here we know that the mercury level in the left limb will be 10 centimeter increase. So this will be decreased. The level of oil will be decreased by 10 centimeters. 10 centimeters. So this height will be essentially 2.9 meters. That is 3 meter minus 10 centimeters. 10 centimeters nothing but 0.1 meters. So 3 minus 0.1, that is 2.9 meters. And the height, this height will be 1.5 plus this 10 centimeters. That will be 1.6 meters. So let's take this as two cases. First is the initial given state. This is case 1 where a PW is exerted. Let's rub this off. Only a PW is exerted in the water and a P0 is exerted in the oil. Here in the right limb, in the water, there will be a pressure PW that was initially exerting PW and an extra delta P for making this mercury level same. This is mercury, and to make this mercury level same, an extra pressure of delta P is exerted. So the question is essentially to find this delta P. So we want delta P, and let's call this as case 2. Let's call this case 2. So what we will do is we will try to formulate an equation for this connecting P0 and PW and this term and P0. PW plus delta P and P0. And we will try to get delta P from that using those two equations. We will write equation for case 1 and equation for case 2. So what we can write here, so let's scroll down a little bit so that we can write. So here the pressure in the left limb can be calculated as the P0, the pressure exerted by oil, plus 3, the height of the oil level, oil in the manometer, into the specific gravity of oil that will give the pressure at this point, and for the corresponding point in the right limb, we can write it as PW, the pressure exerted by water, plus the water level 1.5 into specific gravity of water, plus the level of mercury till the level we are comparing. So for till this level, the height is 20, there will be 20 centimeter of mercury here. So 20 centimeter is nothing but 0.2 meters, and 0.2 into gamma m. That will be our first equation for case 1. What we will try here is to get the value of P0 minus PW. So P0 minus PW will be 1.5 gamma W. Gamma W is nothing but rho W into G. Rho W is given as 1000. So it will be 1000 kilogram per meter cube into 9.81. G is 9.81. So plus zero point 0.2 into gamma m. Gamma m is nothing but rho of m into specific into acceleration due to gravity. So rho of m is nothing but given as 13,550. Okay, 13,550 into 9.81. 9.81, and we have this term going to the other side, so it will be negative. So negative 3 into specific gravity of oil. Specific gravity of oil is nothing but density of oil into G. So density of oil will be given as 900 kilogram per meter cube. So 900 kilogram per meter cube. So 900 into 9.81. So let's calculate this one. We will use the gate calculator. Let's say the gate calculator. Use the calculator, and it's 1.5 into 9810 plus 0.2 into 13550 into 9.81 minus 3 into 900 into 9.81. So this gives us 14,813.1 kilo, okay, Newton. It's Newton, right? So Newton per meter square. This will be P0 minus PW. And now we will try to formulate the equation for case 2. And let's write it here. So case 2. For case 2, we will try to compare the pressure at these 2 points. So it will be same. So at this level, for the left limb, it will be P0 plus, this is 2.9, it is 2.9 into specific gravity of oil. That will give the pressure at the left limb, and for the right limb we have water, so which will be equal to PW plus delta P plus, this is 1.6, this will be 1.6 into gamma W. So here we will try to get P0 minus PW minus delta P. Okay, so which will be equal to 1.6 into gamma W is nothing but, we have already calculated here, it's 9810 minus this value, that is minus 2.9 into gamma foil. Gamma foil is nothing but 900 into and 100 into 9.81. So we want to calculate this value. So we will take the gate calculator. It's 1.6 into 9810 minus 2.9 into 900 into 9.81, which will give us minus 9 minus 9908 Newton per meter square. What we want is delta P, and we have P0 minus Pw common in this both the equation. So let's call this equation as equation 1, and let's call this as that 2, equation 2. So when we do equation 1 minus equation 2, these P0 minus Pw will be cancelled out and we will be getting delta P. So doing, scroll down a little bit. Okay, we will do equation 1 minus equation 2. We'll be getting delta P, or let's write P minus P. So right hand side, P0 minus Pw minus delta P is equal to 14813.1 plus, it will be minus of minus, so it will be plus 9908 plus 1 Newton per meter square. This will be cancelled out and this minus and minus will be plus. So delta P will be equal to, let's take the calculator, put C and 1481, let's 81, okay, 813.1 plus 9908.1. This will give us 24.721 24.721 kilonewton per meter square. So do we have any option like this? This is nothing but 24.72 kilopascal. We have option A as answer. So this is the answer. We got the answer. Thanks for watching. Please like if you find the video useful, comment for any further clarification, and subscribe to support. Peace.